Alright everyone, it's November 23rd. Alright, let's get it going. Maximum matrix sum. You are given n by n. Oh, it's a square matrix. You can do the following operation any number of times. Choose any two adjacent elements and multiply each of them by -1. Two elements are considered adjacent if and only if they share a border. Your goal is to maximize the summation of the matrix elements. Return the maximum sum of the matrix's elements using the operation mentioned above. So I think I can use it any times I want. And we just need to find two adjacent elements and multiply each of them by -1, which means if I find adjacent -1s, I shall do that. Look at the first example. Okay. Oh, okay. Well, a number can be anything. 250 by 250. Holy crap. Interesting question. I think we have a spider. I always have a very soft spot for spiders. But I think our cats might get to it, so let me deal with the spider first. Okay, I got a spider. I got it. Man, where did I put it? I think I'll put it in our plants. Oh shit. Alright, I had it for a while, but I think I dropped it. Now I don't know where the spider is. But it's fine. I just hope my cat don't get it. Alright, so you have this, right? -1, -2, -3. You have adjacent ones, you can turn times -1. You have this one. This is an interesting trick. You have basically positive, negative, negative, positive. So you can multiply by negative, turn this into a positive and this into a negative, and multiply negative, turn them into all positive. So that's kind of a pattern, right? Whenever you see a pattern that is, right? This you can turn this. Of course, you can also have this pattern. The same thing, right? What other patterns can you find? What if I have this pattern, plus, plus, negative, negative? Yeah, this pattern also works. Of course, I can have negative, negative plus, negative plus, or plus, negative. So if I have 4, I can say it doesn't matter how, as long as it's the same number, it can always turn everybody into positive. So what I cannot turn is, let's say we have odd numbers. If I have odd numbers, I can turn 2 of them into positive, and then the rest, you'll always have a negative. Which means, if I have, what if I have a pattern like this? You can always do that, and then you can do that. Oh wait, hold a second, this is an interesting pattern. Negative, positive, negative. Right, when that happens, you can always do this, and then do this. Hold on, I think I'm finding some patterns here. I think as long as I have an even number of negatives, you can always turn them into positives. Right, I can have like, I don't know, I can have a negative here and a negative here. It doesn't matter because I can flip. Right, I can flip, 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 and then eventually they can go, which means it does not matter how many negatives there are. As long as we have even number of negatives, they can all be turned into positives. It doesn't matter where they are because you can always do that, right? So it turns out all we want to do is to find the number, the smallest number, and it will assign the smallest number to be negative. That's it. So we start by going through everything. We'll find the value with the smallest negative, okay? And we find a value with the smallest absolute value, and we will count how many negatives there are, and I will get a sum. Okay, yep, I think we have a solution for this. Very interesting question. All right, let's do this. So we have S is 0. Minimum is, I don't know what the minimum should be. 10 to 1, 2, 3, 4, 5, 6. And count negative, right? For I 0 smaller than matrix dot length plus plus. Okay, S or plus equal to math.abs matrix I and j, min equal to math.min math.abs matrix I and j, count negative, well, plus, I can just say if matrix I and j smaller than 0, count negative plus plus. Okay, if count negative mod 2 is equal to 0, we'll just return s. Otherwise, return s minus min. Okay, we're gonna run through this first. That is correct. Yep, should be 2 times. Yep, should be 2 times. Int v equal to matrix I, j. If v is smaller than 0, v equal to minus v. And then I can say this, and then I can say we delete these two. Okay. Hmm. $19.75. So the key is to realize that as long as there are even number of negatives, they can always be converted to positives. Thus, if the total count of negatives is even, the result is the sum of the absolute values of everything in the matrix. Otherwise, one value must be negative, right? Now to make the total sum max, we pick the smallest absolute value to assign the negative sign. Okay. I have to run one more time. Check it. Looks good. Does not look good. I do not understand. What? I would just get a V. That was the same algorithm as before. What did I do wrong? Yeah, smaller than 0, we just make it into positive. If the logic is 0, we just go with it. And then we always add its value, right? Oh, you forgot the count. Oh, you forgot the count. Yeah, I do forget the count. Sorry, completely forgot about the count. Alright, this one should be right. As usual. As usual. This long thing is always catch me off guard many times, but kind of getting used to it. When we swap to C++, we have to deal with this one more time. Okay, so this is done, which is good. We can do this, so we can do this, but I kind of don't want to do either. I kind of want to, I don't know. Is this over? Has ended. I don't know, I'm just suddenly curious. I'm gonna take a look. Minimum positive sum subarrays. Just, doesn't really have any real. I just suddenly got interested. Let's take a look. What is it? You're given integer array nums and two integer L and R. Your task is to find a minimum sum of a subarray whose size is between L and R and whose sum is greater than 0. Return the minimum sum of such a subarray. If no such subarray exists, return -1. Alright, so we have this, and we have two integers. We're going to find a minimum sum of a subarray whose size is between L and R. So between 2 and 3 in length, and whose sum is greater than 0. The minimum sum. Okay. So in this case, if we choose 2, then we have 1. This is negative. This is very big. Or we choose 3. So the answer is 1. Okay. So in this case, again, 2 to 3. Output is, wait, hold a second. And whose sum is greater than 0? Why you got -1? Oh, because if no such subarray exists, then you get -1. Ah, that is correct. Okay, constraints 100. So you basically, I think you can brute force this. What if you don't want to brute force? Can you not do brute force? So basically we have an array, right? We have array and something. And now we have a range of subarrays from the smallest to the largest. And what you want to know is the sum, right? The sum. You want to find out what is the... You want to find out the minimum sum of subarray whose size is between this and whose sum is greater than 0. It's greater than 0. Let me think. Greater than 0. Maybe a prefix sum will be more helpful in this case, right? If I do a prefix sum, okay? So I have a P0, P1, P2, Pn, right? Technically Pn -1, ending at this. Ah, okay, I see what you're doing. You can put a 0 here. But anyway, so we have the P sum, and then we have the range, which means for each number, I will look before 2 or 3. Not 2 or 3, we'll look before. Ah, that's why you can brute force it. But then, yeah, again, that is a brute force. I mean, we can do brute force for sure, but I still think maybe there is a better way, right? There's maybe a better way. I have this constraint, which means I can minus this, I can minus this, right? I can minus these things. So what I want to find is, and it could be negative. All right, let's just brute force this. I don't know if there is a better way than brute force. Maybe there is one. I don't know. Maybe there is a better way. Right, what we're trying to find is with the lens this, when I lens this, what is the smallest? That's larger or equal to 0, or larger than 0, which means for each number I need to find here, here, here. Are you larger than? Are you larger than? Are you larger than? I don't know. I don't know. I'm just no. I'm just thinking maybe this will help. Right, and we just say that's 0. Okay. Now is the S. No. S is 0. This is smallest. I will call it S. Right, S is equal to 0. So we always do S plus equal to numbers J. Right. And then if, and also we have I equal to 0. If J minus I plus 1 is larger than size, then S minus equal to nums I, and then I plus plus. If S is larger than 0, rest equal to minimum rest S. And at the end, we'll return rest. Okay? So we say rest equal to math.inf for size in range L to R. Rest shall equal to minimum rest self dot sliding window nums size return rest if rest smaller than math.inf else negative 1. Yeah, this is absolutely completely brute force. Huh. So what could be the largest value? 1,000. 100,000. Let's do 1 million then. 1, 2, 3, 4, 5, 6. Incompatible. Oh, that's fine. Say 1, 2. Oh, we have to change this one as well. 1, 2, 3, 4, 5, 6. Okay, that's the same thing. 1, 2, 3, 4, 5, 6. Okay. Absolutely brute force. I don't know. I couldn't think of a, say, smarter way of doing this. And it's not correct. You gotta be kidding me, man. Why is not? Oh, I see. If s is larger than 0 and j minus I plus 1 is equal to size. Okay, so this is brute force. Absolutely brute force. Absolutely brute force. I think we'll pass, but I don't really think it's anything good. The sliding window brute force? Sorted list. Prefix. Yeah, bisect left. How do you use sliding window? Oh, are you telling me that you'll expand wait, hold on. Okay, I have the kernel length. Yeah, this one squared. Yeah, I don't know. Yeah, we just do it for fun. I think I haven't done this for a while. Ooh. Wait a second. I think that was from context. Oh, it's not continuous. Ah. All right, but anyway, we have hit 30 minutes, so we'll call it. We'll call it. Wait, just for fun. You shall do this, right? You shall do this. I didn't do this. Did I do this? I did. I did, but it was a quite struggle. Yeah, I remember this one. So we have to do it. Oh, look at that. First and third will win a backpack. 4 to 10th will win a water bottle. 11 to 16th will win a big old notebook. Holy crap. That is... "50 minutes solving 4 problems. Sometimes it took me that long to solve one." Yeah, the difference is very fast. Anyway, that'll be it. That's for fun. Maybe I'll do another one. I'll see you guys.